we can see natural logs and we can see the natural base inside bigger word problems, bigger applications. And here is an actual real-life example of when a natural log could be used. And the situation we have here, students in a psychology class took a final exam as part of an experiment to see how much of the course content they were retaining as time passed. They took equivalent forms of the exam in monthly intervals after. So we have a class, they took a final exam, and every month after that final exam they kept coming back in once a month and they would retake the same exam, and this was a way for the college to process how much were they remembering as time passed. So we do expect that retention does go down over time. You know, we forget things when we don't use them every day. But here is a model. The average score for the group was modeled by this function. F of t equals 88 minus 15 natural log of t plus 1. Now over here they give us some conditions, and they tell me that t has to be greater than or equal to 0 but less than or equal to 12. And since t is representing the number of months, this is saying from 0, from the time they took the exam, up to a year, for 12 months after that. So time was anywhere between 0 and 12. So just understanding what's given to us. All of that's given to us. All they ask us in this problem is, for part A, what was the average score on the original exam? So the model that they gave us this function, 15 times natural log of t plus 1. And they want to know, okay, what was the very first average on the original exam? Well, if you look at this formula, this function here, the only variable we have is a t. So that's all we're literally going to have to plug in. And if we want to know what time was, if it's on the original exam, no time had passed. They didn't come back after a month, 2 months, 3 months. This was on the very first time they took the exam, so no time had passed. So we want to evaluate time at 0. When they originally took the exam, no time had passed. So this is 88 minus 15 times natural log of 0 plus 1. And again, this is just plug it in and follow your order of operations to finish the problem out. So here we get 88 minus 15 times natural log of 1. Using the properties that we just found, we know that the log of 1 is equal to 0. So this is 88 minus 15 times, now remember, this 15 is being multiplied by this natural log. And properties of logs, so anything times 0 is 0, so we get 88 minus 0. So my answer here, at the original time the students took the exam, their average was an 88. Okay, so from there you can see part B says what was the average score after 2 months, 4 months, 6 months, 8 months, 10 months, and 1 year. Well, guess what we plug in for 2 months? That's our time. Plug in 2, plug in 4, plug in 6, 8, 10, and 12. So this just becomes an evaluation problem is really all we're doing. So at 2 months, when time is, or the average score after 2 months. So when time is 2, I'm going to take my function, 88 minus 15 times the natural log of t plus 1. So that's going to be 2 plus 1, so natural log of 3. And plugging this in your calculator, and I'm just going to do approximations here, just round them to just say 1 decimal place, and you should get 71.5 at time equals 4. So I'm just plugging right back into my original function here, 88 minus 15 times natural log, since I'm plugging in 4 plus 1, which is 5. For your calculator work on that again, follow an order of operations. Do natural log of 5, multiply that by 15, so you would have natural log of, not 15, natural log of 5 times 15, and then we would subtract that, in other words, make that negative, add our 88 to it, and we get, on this one, 63.9. So that's just a matter of following, all of this is just a matter of following your order of operations. So plugging in 6 will give me 18 minus 15 times natural log of t plus 1, so 6 plus 1, which is 7. And when you plug this in, you get a 58.8. So you can see what's happening here. The retention, the averages are slowly decreasing, and that is kind of what we expect. We hope that that doesn't happen. We hope that students retain the information that they learn in class, but we know that we do lose things from time to time. So after 8 months, that would be 8 plus 1, so plugging in 9, do natural log of 9 times 15, get that answer and subtract it from 88, and you'll get a 55 on that. After they gave us, the next one was 10 months, this will be 88 minus 15 times natural log of t plus 1, so 10 plus 1, which is 11. Plugging that into the calculator, you should get an answer of 52. And t equals 12, which is 88 minus 15 times natural log of t plus 1, so 12 plus 1 is 13. And you should get 49.5 on that one. We'll do that one and just show you one more time in the calculator. We're going to take the natural log of 13, multiply that by 15. Going to make that negative since it's negative right here. That's where that negative comes in, the subtraction sign. So add 88 to that, and we get 49.5, which is what we should have gotten. So just make sure you're following your order of operations and working your calculator the right way. So obviously retention is decreasing, and it says sketch a graph. We're not going to actually sketch the graph. We don't have to really worry about that on these. We've learned how to graph the basic exponentials and the basic log functions, but it says describe what the graph indicates in terms of the material retained. Well, I don't have to see a graph to see that retention is decreasing. Okay, so there is one application, there's one way where logs can be used in a real-life situation.